Good morning, bom dia a todos. Julgo que podemos começar. Eu vou fazer a introdução. Professor Marcos Hall, I apologize. I will do your introduction very briefly in Portuguese first, and then I will go. Vamos então começar a sessão. Portanto, temos connosco o professor Marcos Hall. He's a professor at the Department of Evolutionary Biology and Environmental Studies at the University of Zurich in Switzerland. As an environmental historian, and according to his CV, which is great, I think we'll have a very beautiful presentation today. He aims to better understand human relationships with the natural world, using clues from landscapes as well as written records, has asked questions about the history of ecology, ideas of wilderness, our experience with invasive alien species, circadian rhythms, welfare effects on nature, and the past of malaria control. By drawing mostly on case studies in North America and Europe, Hall has published books about ecological restoration, mountain environments, Italian natures, and mostly recently mosquitoes. He's currently working on a cultural history of parasites. This is a very hot topic nowadays, and I'm sure that we will have a very, very, very nice presentation. And so I'm giving the floor to Professor Marcus Hall immediately, and after his talk, we'll have time for a few questions. So thank you very much, Professor Marcus Hall, for this opportunity that you give us to share your knowledge. And in the name of the University of Coimbra and the organization of the Congress, I really would like to welcome you and thank you for this opportunity. Thank you very much. Please, when you like to start, please go ahead.
Thank you, of course, Professor Freitas, for this generous introduction, and all of you who managed to come on a beautiful Saturday morning, at least here in Switzerland. And hearty congratulations to all the organizers. I was able to catch much of the meeting yesterday, and I was really impressed with the trilingualism, the energy, and the topic itself, which of course is so important right now. And so to bring historians together with archaeologists and ecologists and a lot of other disciplines is impressive indeed. What I have today here is just some recent work on parasites that I've been working on for quite some time, actually, and it's led me in different directions. And I hope to offer a taste of some of what I think is more of the exciting work. And I hope it overlaps some of these areas of ecology and evolutionary biology, as well as history and history of science. So I'm trying to catch a number of people here with your own backgrounds. My own training is ultimately as a historian, though I've done forays into biology and history of science. So really I'm coming at this as a historian, but I hope to interest everybody else who might be out there looking at these subjects. So let me share my screen here and see if we can do this. And I'll go like that. And then make sure that everything's in good shape. If something's wrong, let me know, but I see my screen, and I hope you can see my screen, Learning to Love Our Parasites, and looking at how...
Professor, could you put it full screen?
It is full screen in my screen.
It's full screen? Okay.
Is it not full screen?
No, it's full screen. No, it's great. Yeah, it's okay. It's okay. I apologize.
Okay, good. So, really it's an overview of parasites to begin with, and the issue of parasites as one of our most important creatures. There's a good deal of research on human-animal relations, and so human-animal relations could include such animals as the small ones in our intestines and in our veins, and the really small ones, which might even be microscopic, that we cannot see at all. And so biologists tell us that up to 80% of all species are in fact parasitical, at least in a relationship. And so this ecologist, Paul Hudson, says make these parasites then are important players, not only important players, probably crucial players in ecosystems. And so one study mentioned that 5 mammal species in North America that are endangered. If those mammal species, and I believe they were ungulates of some sort, if those species themselves went extinct, they would usher into extinction 56 of their own parasites, because so many parasites are very species specific, not all but many. And so here's just a multiplier factor showing how important these parasites are. In human beings, there are lots of parasites, and these are microbial to visual. And so just in this categorization, which represents multicellular parasites, this study suggested that there are over 400 parasites on most human beings, and 23 are extremely common. And that may make us begin to itch and wiggle and wonder where all of those parasites are. But if you don't have those parasites, then probably something is not quite right. Another study said Homo sapiens rank amongst the most parasitized of all animals. Our varied habitat and diet and our global distribution exposes us to more infections than any other species. And this is due to the fact that humans live in so many different places, and our diets are so varied and constantly changing. And so we are essentially bundles of organisms, and most of you may have heard the factoid that we actually carry more bacterial cells in our body than we do human cells, and that number has fluctuated from 10 times more to a mere maybe twice as many. The point being is that our bodies are sacs, we're receptacles. This brings into question all sorts of issues about what are human beings, what are we? If most of what our cells are not in fact human, are we simply walking around with all of these other non-human cells and doing them a favor more than we are doing our own human cells a favor? So part of the major question for this project about parasites comes from the fact that in our 7 neglected diseases declared by the United Nations, a lot of those are, in fact, let me just get this darn thing out of my way here. A lot of those are, in fact, parasites. In fact, all of these pictures of schistosomiasis, trichuriasis, hookworm, etc., these are, in fact, worms, flatworms, roundworms, many of these visible to the naked eye. The last one, trachoma, is a bacteria. But what makes this so amazing is beyond these horrific deaths and diseases and debilitations that these worms cause and these parasites cause, so many more people actually carry them without any or very few effects. So schistosomiasis, actually only 1 out of 1,000 people succumbs to the disease, whereas all the rest are parasitemic. They're carriers of the worm, and that goes down the list. Hookworm, look at that one. Only 1 out of 250,000 people actually suffers mortality from being infected by hookworm. There was a huge hookworm campaign 100 years ago to try to get rid of these worms, the assumption being that they're debilitative and fatal in many cases, but that simply wasn't the case. And so the question here arises then, what are all these creatures doing? What are they doing to us? And if we're historians, then how are we supposed to explain what these creatures are doing in our lives and lifestyles? The big one, of course, through time has been malaria. Malaria is considered to be probably the most deadly of all parasites, because ever since humans have wandered the earth, which is about 200,000 years ago, malaria parasites have been in our veins. More people, it has been estimated, have died from malaria than any other parasitic disease. And so I once ran the numbers, and it was terrifically high numbers, in the order of billions of people actually have died from malaria. However, again, these statistics are so strange because at least today, one person will actually die from malaria, and the other 570 will contract malaria but survive it. And then there's the other condition with malaria parasites, in that they can actually infest your body and be in such low metabolic levels, say in your liver, that you can't even detect them. So they figure at least twice as many people host Plasmodium undetected, 1/14 of humanity currently, and the fractions were so much higher a century ago. So again, the question looms: what are all these creatures doing? If they're not all dangerous and fatal, which these numbers show us, what are their other effects? So a biologist would look at these issues and say, well, what is a parasite? Does that include viruses? Does that include bacteria? Or is it just the big creatures? Does it include insects or arthropods, which are more ectoparasites? Does a parasite necessarily and ultimately hurt its host? By definition, many times a parasite is something that freeloads, or that depends on another creature, and usually deleteriously, at least in a traditional sense. Actually, it's been since the 1870s that a naturalist, von Beneden, came up with the tripart notion of mutualism, commensalism, and parasitism, whereas mutualism would be co-benefit, commensalism would be cohabitation, and parasitism was where one creature actually depended on and damaged the other creature. So already there's an understanding here in the 1870s that there's variations of these creatures. The difference between a parasite and a pathogen is fundamental, because pathogen by definition means it promotes sickness. A parasite is a creature that lives on another creature. At least that was the notion in the 18th and 17th centuries. But evolutionary biologists tell us that this union of host and parasites has to be beneficial in some ultimate sense to both creatures. Otherwise, over evolutionary time, chances are one organism will win out and eliminate the other. Either the host will be successful in eliminating the parasite over time, if the parasite is truly deleterious, or vice versa. If the parasite is indeed deleterious, it will wipe out the host, and you'll have this very unstable relationships. But we know that humans have always hosted malaria parasites, at least, and so it hasn't been unstable. It's been this waltz down time between turning, when one turns left, the other turns left, and one turns right, the other turns right, and so it has somehow been stable, and we need to figure out why that's the case and what that means to human societies. The issue that I mentioned before then is parasitemia, or the cost of expelling parasites. Is in one case more than hosting the parasite. So they just sit there, and the parasites then inhabit bodies, inhabit hosts, and do so, and attempt to do so without hurting the host terribly. Otherwise, it wouldn't continue in this relationship. So those are all really biological questions. Historians of science then would take up the issue of what is a parasite again? When have parasites become biological, because they used to be human, and I'll get more into that in just a moment. And then the issue of metaphorical parasites, which we use all the time today in our language. Another ongoing question for virologists and other biologists has been whether parasites actually become more virulent or more dangerous over time, or vice versa, whether they become less virulent over time and begin to cohabitate. So that's another way of sort of a chicken and egg question of saying which came first, the parasite or the symbiont. And in many cases, the scientists would be quite in disagreement over this issue up until this day. Generally, the notion is that a parasite has to learn to live happily with the symbiont and not damage or enrage the symbiont, the host. Otherwise, this relationship would fall apart again. So it's really an issue of symbiosis. When does parasitism turn into symbiosis, or does symbiosis turn into parasitism? And that's part of a reflection of what's going on in society at the time. Peter, like Charles Darwin said that there's a great deal of competition in the 1860s and 70s. And then there's Kropotkin, who's the Russian naturalist turned social scientist, who then says cooperation is really the key. And they actually both talk about the issue of parasites, and parasites then are sort of the emblematic competitive creature that doesn't cooperate. So parasites are aberrant creatures that don't belong. And the trying to find cooperation or competition within the human world, then these naturalists are looking at the animal world to see this in the human world. So we finally get to environmental history and the world of environmental historians, and it's an attempt to look at both the biological issues and the environmental or the scientific issues through time. And I like to start with this classic and accepted paradigm that Alfred Crosby and William McNeill told us a couple decades ago about how pathogens and disease have been exported around the world, especially by Europeans, to fall on immunologically naive populations, these so-called virgin soil epidemics, so that indigenous Australians, indigenous Americans, Hawaiians around the world then succumbed over the next centuries after contact to Europeans by enormous and dramatic and horrific numbers. This is pretty much accepted, and it plays itself out today. So lots of the isolated parts of the world, even now, are just sort of being touched by coronavirus. And so these are sort of the histories of epidemics all over again. But I think within this grand story of exportation of pathogens, there's a missing of the acknowledgement of parasites and symbioses, and that is these organisms that are not necessarily deadly, or if they're deadly, then they do so to the enormous advantage of the host that is exporting them. So René Dubos, an amazing philosopher, physiologist, and I encourage you all to visit his books again. Living things, he says, in a mirage of health, constantly harbor a host of different kinds of microbes, some of which contribute to their well-being, while others become the cause of disease under certain circumstances. And this is the complication, in that parasites can sometimes be pathogenic and sometimes symbiotic. So the main questions really that I've been trying to throw some light on and hope to talk about more here is, how does human history change when we focus on parasites instead of pathogens? And that's to narrow in on this question of what are the benefits of being parasitized, either historically or in a contemporary question. So you have to look at definitions. Really, a parasite comes from parasitos. That is a person who would eat on another's table, a person who receives free meals in return for amusing or flattering remarks. So the first parasites were human, and they would generally make sure that their hosts were being taken care of, and in return the hosts would provide them with shelter or food. So we still use parasite today in this metaphor, in this human sense. It's an organism living off another, hence a freeloader. And this guy says, I want to get rid of those two parasites, and he's going to the local insecticide store to do that. This Joseph M. Benedin, who was Belgian, wrote this amazing book called Animal Parasites and Messmates, which was translated from the French, and it's sort of a strange title that they gave it in English. But he's a naturalist who spent his life looking at parasites and creatures living on other parasites, especially marine organisms. And he said simply that the parasite is he whose profession it is to live at the expense of his neighbor, and whose only employment consists in taking advantage of him, but prudently, so as not to endanger his life. And so he says that parasites have to be very careful. They don't want to be pathogens. They don't want to kill their hosts. So there are all sorts of examples of the benefits of parasitism that naturalists have basically discovered in the animal world. Intestinal worms may help detoxify sharks of their heavy metals. What were formerly considered parasitic and pathogenic are now seen as symbiotic. Mistletoe, growing on trees, which we see now in the fall all through our forests, at least here in Switzerland, they may actually serve some sort of function in dispersing the tree's seeds because they attract birds, and the birds then eat the seeds and may disperse the seeds, so that this mistletoe, once parasitic, is now seen as symbiotic. Grapes, more closer to many of our hearts, they depend on microbes for producing distinct flavors and odors. And so we have to thank these microbes for the different wine tastes that we have. So these microorganisms and these parasites and epiphytes are in fact serving purposes, and sometimes very beneficial purposes. And the take-home message here is that sometimes you can't identify these benefits without extended study over long time periods and intimate conditions. So that leads to this implication of what are the benefits that parasites can produce for people? And we have to assume that there are lots of benefits. So even nasty parasites like Trichinella, responsible for trichinosis, HIV, the virus that lives on T cells or is attacked by T cells, the one here on the lower left, which is a trypanoma, responsible for syphilis, and then the big one, Plasmodium, in the 5 species, which produces malaria. So how can disease itself be beneficial to an individual or a species? And that's a wider question still. And René Dubos once again says, complete freedom from disease and from struggle is almost incompatible with the process of living. So some quick benefits that you may have heard of. Certainly you know that our food wouldn't be very well digested without a lot of those Escherichia E. coli that we have in our intestines and other types of bacteria. So they help aid our food. Can we call those bacteria parasites? Maybe, but they're certainly foreign creatures living in our bodies. More directly, bacteria, fungi, archaea, viruses, and mites help guard against UV damage. There's the hygiene hypothesis that you've certainly heard about, and so that if we take too many antibiotics or don't have vaginal births, then we don't have those rich floras and faunas that are part of our systems, and so the body might be not used to not having those in our systems. And so Martin Blaser has written an important book about the possible maladies, the problems that can arise from not having those bacteria that are, or the parasites and the symbionts that our bodies have been so used to having over the millennia that our bodies have evolved through time. So there's a number of folkloric tales that support the benefits of parasites. In ancient China, according to one source I found, 3 tapeworms are a sign of good health. Lice in the Middle Ages were possibly a sign of good health. And a classic story is that when people were on their deathbed, deathly ill, sometimes the lice would leave the body and they would be understanding that that host was no longer going to be viable for very long, so that they would seek another host. And so the presence of lice was considered a healthy sign. Leeches were used for bloodletting, if you can consider leeches parasites. Maggots used for wound cleaning. Of course, these are the megaparasites, or at least animals that can live on our bodies. So here's a wonderful quote by Alfred Crosby. These ships were like giant bacterium. If I can read it by moving some of my, here, I'll bring this to the bottom. Giant viruses fastening to the sides of gigantic bacterium and injecting into it their DNA, usurping its internal processes for their own purposes. So this is happening in the Caribbean 500 years ago, in New Zealand about 250 years ago. And then we know the terrible tales of what happened thereafter. Demographic collapse in central Mexico from 24 million, according to this estimate, down to 500,000. Same story happens in New Zealand, from 200,000 individuals, more or less, down to merely 50 or 1,000 at its nadir. Tragic tales of virulent diseases exported from Europe. And it happens at all scales. Little islands off of New Zealand, the Chatham Islands, 2,000 individuals down to a merely 20 or 30 individuals 200 years later. This is a Crosby and William McNeill story that we all know and certainly should appreciate. And it goes on to deal with species, which are much the same story. The susceptible ones, like the moa in New Zealand, drop over time. This graph's a different orientation, but it shows you that the cumulative extinctions absolutely go up geometrically over these 300 or 400 years since European contact. That's part of the ecological imperialism that Alfred Crosby talks about in his excellent case study of New Zealand. John McNeill, this book you're probably familiar with, came out a decade ago, and it complicates this his father's thesis, William McNeill's thesis, and he says it was really a 1-2 punch, or maybe a 1-2-3 punch, so that the arriving Europeans brought their smallpox and typhus to kill the indigenous peoples by the 90 percentile, and then their generations after them in the subsequent century themselves became somewhat immune to the next problems of influenza, mumps, and measles, and these sorts of issues, so that subsequent colonists, say from England and France, would not be able to defend themselves against things like yellow fever at the bottom and malaria and cholera, which provided a shield for the second newcomers. The first newcomers had the advantages of their own pathogens, and then acquired immunities over the subsequent centuries allowed them to defend these territories from subsequent invaders. And so places like Haiti, with the coerced migration of African Americans going to Haiti, they then were relatively immune from such issues as yellow fever and malaria, which the white French and the English were not able to defend themselves. So that's all part of the Mosquito Empires book, and it's a way of showing that acquired immunity is this process of immigration. So back to our parasites, and we have to realize that they can be symbiotic or pathogenic, or even in some cases curative, and in rare cases even mind-altering. And so there's all types of creatures and bugs out there, and they may have different effects on human societies. So first of all, if you look at pathogenic parasites, take the perspective of the colonizer and not the colonized, and through what ecologists would call enemy release, the colonizers shed their own pathogenic parasites, and it was the best possible weapon they could have carried with them were their own pathogens and their own parasites. And so here there were enormous benefits for the colonizer of these parasites. So in the next few minutes, I just want to review the benefits of being parasitized. And then the acquired immunities provided the colonizers with extra defenses in subsequent decades. If you think about the pathogenic parasites, still you can think about the evolutionary adaptations like sickle cell anemia, or just call them sickle cells, and G6DB deficiency, otherwise known as favism, and all the thalassemias. These are all blood adaptations to the malaria parasite, and in malarial environments, it's actually more advantageous to be heterozygous sickle cell than not have these heterozygous sickle cells. And that goes for all the other deficiencies there or adaptations. And so this is a strange situation where if you're bringing sickle cell in your body, at least heterozygous sickle cells, into a malaria environment, you have those advantages, and as opposed to the people who don't carry these adaptations. And so in the New World, these sorts of genetic or evolutionary adaptations were highly advantageous. If you carried the parasites and had a malaria environment, it meant that your competitors, the ones who didn't have sickle cell, didn't have favism or thalassemias, would actually be at a disadvantage. And so this would be an indirect advantage of parasitism. But then straight to symbiotic parasites, and that is the case where it's very useful to be continually, in many cases, continually exposed to some parasites, otherwise you lose your acquired immunity to them. And this is the case in Madagascar in the 1960s. What happened is they were relatively successful at eradicating malaria, but not completely successful, so that in the coming decades, the 10 or 20 years afterwards, people lost most of their acquired immunity. Malaria returned in the 1980s to be much more virulent and deadly than it was before. And so it's by providing this continual exposure to malaria that these parasites were so useful. Knowing that those parasites might return, the strategy might have been to leave a small reservoir of those parasites circulating. The really interesting story, and I'll just read this because it's from a work that I'm working on, it's the stories of the USA's immune regiment. And the immune regiment was created in the United States during the Spanish-American War of 1898. And here the disadvantages of not being parasitized were demonstrated. African-American soldiers were the subject of a special recruitment campaign because of their supposed resistance to tropical diseases. Popularly known as the immune regiments, the U.S. Congress called for 10,000 recruits made up of men, quote, who were owing to their origin, the places of their residence, or other circumstances affecting their physical characteristics, possess immunity or are likely to be exempt from diseases incident to tropical climates. So there was a key battle of San Juan Hill in 1898. A regiment of black immunes were sent to the front lines to rescue the white soldiers who were debilitated by yellow fever and malaria, but with the surprising result that some weeks later, many of the so-called immunes were themselves becoming sick with the diseases. In their war tactics, the generals were discovering that immunities might wane or diminish in people lacking continuous exposure to a parasite. In fact, to reap the full benefits of hosting Plasmodium, soldiers with more recent exposure to the dreaded diseases would have made better recruits in this war. Freshly arriving immigrants from Greece or the Mediterranean, including Portugal, would have probably been, and with much wider skin than the immunes, would have probably made much better cannon fodder in the Caribbean battles, since these Mediterranean lands were at that time still endemic with malaria. In their war strategies, the U.S. government could have been more racially neutral than they might have guessed. So those are the issues of the disadvantages of not being parasitized, playing itself in a very racial way in the United States. I can see the clock marching forward, but there's so many interesting points. Malaria therapy itself is advantageous because it's a method that was used to fight tuberculosis in the syphilis in the 1920s. Essentially, people would be inoculated with the malaria parasites. Enormous high fevers would be induced, and mysteriously the high fevers would be a remedy to taking away some of the symptoms from syphilis. And so Julius Wagner-Jorig won the Nobel Prize in Medicine in 1927 for this process called malaria therapy, and it depended on the benefits that parasites produce in creating high fevers, or pyrotherapy in a way. Curative parasites are amazing because vaccines themselves depend on one's body building up antibodies against attenuated parasites. So here's parasites that are damaged and they're flicked into wounds or injected into bodies, and those attenuated parasites then can produce the antibodies necessary to fight the full pathogenic parasites. So variolation, which is sort of a forerunner to vaccines, or the practice of flicking liquids of smallpox onto unexposed people. And so you could say, here we have a parasite which we're using, or in this case, a bacteria with a smallpox, or a virus with in case of smallpox, and it's actually being used in the process of immunization. Cowpox vaccines relied on other vaccines. So the whole process of vaccination, you could say, is a benefit, a curative benefit. And there is some evidence that salmonella helps resist the plague, at least there's reports. And leprosy, mysteriously, if people had leprosy during the era of the plague, it seemed to provide some protection against the bubonus bacterium. And so those are still histories of ecology and disease ecology that are still being worked out. Point is that disease organisms can produce all sorts of beneficial properties. Lastly, I'm getting to the end here, and that is that mind-altering parasites are indeed part of our benefits of parasitism. And the really famous case of Toxoplasma gondii, which is a favorite test subject these days. It's another plasmodium or a eukaryote. It's widely found in households, in our household cats, because this parasite depends on a two-part host, the rat or mouse and the cat. And basically it's assumed or observed that rats will throw themselves at cats because they're attracted to the urine of cats, and they wonder, why is this mouse essentially committing suicide in front of the cat, which will gobble it up? And it has to do with the odors that the Toxoplasma gondii can produce in the cat urine to attract the mouse. So as things, most things parasitical, they're very complicated, and you have to know more of the cycles. And so some of these Toxoplasma gondii get passed on to us humans. And this is a take-home message. If you're a cat owner, chances are you may already have Toxoplasma gondii in your veins. They say 10 to 20% of most Westerners already are infected with this particular parasite. In places of cat-loving France, the French are supposed to have more than half of their citizens infected by Toxoplasma gondii. The assumption is it's bad for us. It creates all sorts of neural tissue damage because that's where the parasite is harbored. But then other studies are beginning and creating such issues as encephalitis, ocular diseases, epilepsy, schizophrenia, bipolar disorder. These are all terrible things, and we say, well, maybe we should get rid of our cats who are giving us this Toxoplasma gondii. But other studies are using big data sets to say, well, maybe these Toxoplasma gondii are improving our cognitive control. They claim in some studies that women give birth to more sons and that men become greater risk takers. So this could all be due to Toxoplasma gondii. The studies are still out, but the point here is that maybe it's not just pathogenic, but in some instances, perhaps beneficial. I think we need to study this one a bit more. Beware of parasitic determinism. Not everything happens because of our parasites. That's what my friends remind me as I get deeper into parasites. But we do have to realize that we're superorganisms, we're transported landscapes, and our landscapes are also our bodyscapes. And in many cases, it's better to bring those bodyscapes with you when you move. And that also goes for all of our animals that we surround ourselves with. They are loaded with parasites, and they are having effects on their own hosts. The big question, I'll end you with this one, and that is back to our malaria parasite carried by a mosquito, we can then go to the next level and say, should we be thinking that our mosquitoes are not always bad? Our mosquitoes carry the parasites. 430 of 3,500 are carrying malaria parasites. And in fact, in Greek, anopheles means not beneficial. But we have to question, is this mosquito really beneficial? It can move into malaria-free lands and provide all of those benefits I mentioned earlier. It can help maintain acquired immunity. It can promote evolutionary adaptations. It can transmit less virulent substitute parasites like Plasmodium vivax instead of the more lethal Plasmodium falciparum. It can help produce fevers such bizarre remedies as malaria therapy, all due to the mosquito, and it may enhance some of our physiologies. There's studies that suggest malaria lowers blood pressure, which can itself be blood beneficial. So maybe the parasite moved by the mosquito is not bad after all. Generally, mosquitoes may be accomplices in carrying all the parasites that can be so useful. And I'll end with this quote. Instead of telling a tale of one disease susceptibility colonized by another, Caribbean history can be recast as a broad story about the benefits of being parasitized. Spanish conquistadores benefited from their symbionts, and 2 centuries later, conquistadores' descendants benefited again from their newly imported symbionts. Such benefits are also useful understanding Africa's colonial history, since indigenous Africans born and raised with their immunosuppressed parasites were able to unleash these creatures on disembarking Europeans. The Nigerian defense strategy of cooperating with one's parasites often started in the womb and was further promoted through mother's milk and early childhood. Yellow fever viruses and malaria parasites were being continually transmitted between local Nigerians by mosquitoes, so that these pathogens turned symbionts presented a formidable barrier against English merchants swooping into Nigerian ports to extract what they could. Mosquitoes were thus accomplices with the microbes they carried for fending off European invaders. Little surprised that a resident from a Nigerian town called Ibadan now praises the mosquito for helping protect his homeland against these early foreign excursions. He says, "Let us give thanks, therefore, to that little insect, the mosquito, which has saved the land of our father for us. The least we can do is engrave its picture on our national flag." So that's a reason to celebrate the mosquitoes that celebrate the parasites. So that's all I have for today. I took up most of the time, but maybe there's a question or two. Sorry about that.
Thank you, thank you. No, it was really wonderful, and it's at the same time we are living times where you do feel that we should actually be aware of it, but over the pandemics, my feeling was that it was like a surprise for everybody that we are extremely vulnerable to this, to this or any virus. One thing that really astonished me, it was the surprise that came. Generally, we are exposed to a virus, so it seems that we are vulnerable, and this is a condition that we should accept it as it is, because we are part of this biological network that you just so well explained. So and it was I don't know, do you think that this is really an issue? I mean, that we lost somehow this sense of belonging to a wide network of biological mechanisms and relationships. Is it relevant for humanity to have this sense of belonging and to understand that we are part of it? I mean, then there's this biological balances are out there. I mean, because it's impressive when you show all these, so many and you can show it by reading the history and number of events all over and all the time. What do you think that we can learn from this?
Well, we live in such a sterile world. We're so isolated from all those microbes for the most of us, at least in the West. And so part of the process is bringing some of those microbes back into our bodies. This is what the probiotics and
Yeah.
supposedly do for us. But yeah, we live in a very strange time. And we used to be so, we'd walk on the soil, we'd have bare feet, and we'd be continually exposed to all of these creatures. And only recently have we begun to isolate ourselves from these parasites and microbes, but some of them get by, and so the viruses, the pathogenic ones like coronavirus, go on to do what they need to do. But at least there's a different perspective here of what they do over the long range. Sometimes they are on the side of the host rather than the side of the destructive to the people whom we're moving into.
It's funny because I remember I was, I mean, I cannot see any question in the chat. At least let me recheck, because one suggestion. Okay, many thanks. Marcos is from Inês Amorim. She says the relationship between food consumption and parasites in the context of the 19th century. She's asking if you'd like to answer this.
Oh, so supposedly if we have fewer foodstuffs or a more homogeneous diet, or a diet which doesn't have so many varieties, that might promote certain types of parasites for sure. There's some really interesting studies looking at paleoparasitology.
Yes,
And so I listened to the archaeologic talk yesterday, and so the Iceman, the Utsi the Iceman in the Alps, he actually is loaded with whipworms. And maybe that's due in part to a fairly bland diet of berries and whatever else he could eat up there. And so he didn't have the ability to fight off some of these whipworms. But then there's other studies that suggest that whipworms are not always bad, that they actually have physiologic benefits here and there. So diet's certainly part of it, and our diets have changed a good deal in the last century.
And if we look inside ourselves, I always remember one of my colleagues, biologists, who keeps saying, well, we are carrying 90% of other beings' DNA and only 10% of the DNA is ours. So somehow we are, as you said in the beginning of your lecture, we are carrying with us 90% of, so it's, and do you believe that maybe if we understand what's going on inside, and if we really understand where are the goods, and I mean, or at least the balance between different types of, but anyway, but we are exposed to outside, so this is a tricky issue. I don't know if it's worth to go more deeply inside, because I'm a biodiversity kind of a scientist, and some years ago we felt really angry because a lot of the budget, was allocated to follow and to try to assess what's going on inside, in terms of assessing biodiversity, in all the kind of organs we have, and like if it was the response to that could give us some kind of clue. And it's still a question and a debate in the biology world if we should be.
I wish the philosophers would take up the question of identity about human beings, because
Yes.
we're clearly a huge symbiotic organism, and we think we know who we are, but we're actually just this bundle of cells. So those are almost philosophical questions more than biological or historical ones.
Yeah, it's
But some people have touched on that in some of their work. But no, I hope what fascinates me is you can begin, I hope, to bring biologists and historians together over these questions, these common questions of interest.
Yeah. But we have a question from Cristina Brito, and is more into environmental history, and she says great talk, so thank you for your talk. And And she's asking, can in our environmental history research make the invisible visible, either because we won't see parasites and because they are absent from sources? She is asking.
Yeah, that's part of. I think there's a whole group of scholars call themselves animal-human relations experts, and I think we need to interest them to take up other creatures besides cats and dogs and bears and leopards, and to have them converse with the people doing the human microbiome project. So there's all of these creatures in many ways are more important to us, at least our physiologies and even our behaviors, than the ones that are macroscopic and they're out there, they're inside of our bodies. So part of it might be related to the issue of there's a lot of studies on nuclear power and nuclear radiation, and those were also invisible forces that people were very worried about because they were invisible and small. And I think we have the same issue with our microbes. The anti-vax movement is related to the issue that we're not quite sure what they're injecting into us. And it's small and it's invisible, but it's highly potent. And in some ways, it's more powerful and more important than the big creatures that we spend more time thinking about. Yeah, how to study these, how to find the historic sources on microbes and parasites. The first way that I approached this was to look at the history of parasitology. And so these are parasitology, so that's a history of science project. But then you have to get into disease history and look at epidemics. And then, of course, all of these diseases like malaria weren't understood as parasitical until very recently. So maybe we're limited to more recent time periods as historians, the 20th century, to think about some of these creatures. But no, it's a great question. You have to do a lot of sleuth work, have a lot of conversations with biologists, I think.
And maybe it's time to bring also other organisms that really play some role in this balance and this biological balance even. I'm expecting that fungi will also give us some new clues on these issues.
There's more and more books coming out on
I think that's
on mushrooms.
Entire new world that is coming, and must be amazing even for your kind of research. So I don't know if I just we don't have time for more questions, I think. But anyway, I think that in the audience, they just keep saying thank you very much, Marcus Hall, for your excellent conference. We really enjoyed it. And I will, from my side, thank you very much for this nice chance to learn a bit more on the topic. And
thank you for your generosity in coming this morning, and of course again to the organizers who did an amazing job here and making sure all the buttons work. I'm really impressed. I wish we could do something similar here in my own country here to organize this amazing national conference of environmental historians, which we just don't have the critical mass the way they do in Portugal. So I've really been impressed, and I've been following the Portuguese group for some time.
Thank you very much. Well, have a nice weekend again.
And I'll see the rest of you in some of the other conferences. Thank you, Brother.
Thank you.